Hey everybody, this is Larry. This is day one of the June Leetcode Daily Challenge. Yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. And yeah, so this is the first day of the June. So welcome. I'm planning to do this again for the month. Um, I think I have like a year and like 2 month streak or something like that. So what is that? That's like about 400 something day streak. So come follow and do along, solve it, and yeah, come on Discord and just discuss the problems in general. Anyway, today's problem is going to be max area of island. So I usually solve these live, so it's a little bit slow, or fast forward or watch it on 1.5x, 2x, whatever, however fast you want to listen to this. But okay, so basically you're given them an area of number one. Return the maximum area of an island. Okay, if there's no island, return 0. Okay. Okay. So the so this is just a FUD fill algorithm. So this is pretty standard. There's a couple ways to do it. There's breadth first search or depth first search. The way that I like to do it, because you have to kind of keep track of the area, is just using depth first search. Because for me it feels a little bit easier to keep track of the area. But also the other way of doing it is by union find, but I generally don't do union find unless I'm forced to. That's not really true. I don't mind union find. It's just that for FUD fill, it doesn't I don't do it as much. One thing to note, and one reason why I would use union find over depth first search is just looking at the constraints. Because when you do depth first search, every time you do a recursion, it creates another recursion call, right? Put another thing on a stack. If you have like a big grid, then it actually might you might get into stack limit exceeded or something like that, depending on the language and depending on whatever, and or memory limited exceeded or something like that. So like, let's say m and n is like, I don't know, 1,000, right? 1,000 each. The entire grid is 1,000 by 1,000, which is only a million element, which is big but not insurmountable. But if you try to do it with depth first search and you have a full grid, you're going to do like a million recursion literally. And that actually usually runs out of memory, or maybe not usually, but at least back in my day when computers are slower, maybe now it's faster. But anyway, it's just something like that is something to kind of think about, and therefore use a non-recursive algorithm in general, and union find is pretty good for it. You also do a breadth first search, but I think for me finding areas a little bit messier. But anyway, so let's do a depth first search, and for me, yeah, I can just do like an area of an x and a y, and yeah, let's do rows as you get to the length of the grid, columns as you get to the length of the grid of the first element. Of course, when I write this, I always double check the m and an n, because mistakes have been made in the past where you get a wrong answer from it, when they give you 0 rows to solve. But yeah, and now we can just do like a I will do a done away matrix to signify what's done, and of course this has a linear time cost, because for every grid element we will create a boolean value. And usually I point this out at the end and not now, but I point it out now because you can do this actually in place by modifying grid itself. There are a couple of ways you can modify grid. You could use a higher, especially since it's only 0 and 1, you could use a higher order bid, you could flip grid and stuff like that. And technically, you will use all one extra space, but then you modify the grid, and the person who passed in the input will not be happy, because they will be like, wait, now I get the answer, but then my array is gone for some reason. My matrix is all messed up for some reason. So technically, it's all one extra space. I don't know if they. No, there's no follow up. But I do not recommend it, and it's just, at least for this particular problem, is a dubious decision because there are functions where it makes sense, but in this case, getting the area should. I wouldn't expect to mutate the input. Anyway, so yeah. So if done, we turn 0. Otherwise, we set this is equal to true. Total is equal to 0, and then we turn total. I'm gonna add some more stuff here yet, but what I usually do is I have a direction array, which just lets me set it up, and this is just me going up, down, left, right, which you'll see in a second how this is up, down, left, right, but maybe not in that order though, just to be clear. But I just meant like all the 4 directions, all the 4 cardinal directions that they tell you that you can do. Yeah, sometimes I do it with a for loop, but that's fine. But yeah, and now you have dx dy in directions. This is how I always write it, but this is something that I also kind of refined over time, so you might not write it this way, and that's fine. But just write it in a way that you're consistent about, so that when you're in a contest or an interview, then you do it the same way, so that you're not doing anything, at least not the part that you depend on that new. I call my thing nx and y for like next x and next y. I don't know if it's a great thing, but also still with allergies, but this is, but it is what it is. And yeah, anyway, and we want to make sure that greater than 1 is also 1. If this is the case, we add the area, and that should be pretty much it. Well, that's it for the function. But basically, this is standard flood fill is saying, okay, let's get the area of x and y, and the way that I write it is a little bit close to dynamic programming as well, if you want to put it that way, where it's not quite, because it's not acyclic, but it's just the area of a cell is just equal to the area of all its neighbors, and then combine them. And actually, I messed up. I think this is, you start with 1 for this cell, and then you sum up all the other things. Whoops, good catch, thanks. Anyway, and then now we just have to get the max. So let's set max is equal to 0, and then 4x in range of rows. So now we just go every possible one. If grid of xy is equal to 1 and it is not done, because if we already done it, then don't do it again, just for performance. Otherwise, it becomes n squared, where n is the number of cells, not yeah. So now we get something like this, and then at the very end we just take that. Let's run it real quick. Do they give us another one? Okay, we give us this one. Run the code. Okay, that looks good. It feels good, so let's give it a submit. Yay, accepted. So what is the complexity of this? Well, we only look at each cell a couple of times, constant number of times, right? Because for each cell, it gets checked on by its neighbor, and it only has 4 neighbors, so that's 4 times plus 1 more time from here. So if you amortize it or look at it backwards, each cell gets checked at most 5 times, say, or whatever, times some constant. So we look at each cell constant number of times, so it's going to be linear time in the size of the grid, which is rows times columns, or n times m, or whatever. And yeah, in terms of space, as we talked about earlier, we have this done array that allows us to kind of, not modify the array. And you can also do things that, modify this once and then modify it back. but it's a little bit weird and awkward. And obviously, if you do stuff like that, then your code also doesn't become thread safe with respect to, if they expect your code to be immutable, even though it's fake immutable. But they're like thread safety and stuff, other weird stuff. So so I still don't do it. But yeah, but that's all I have for this one. Max area. Yeah, let me know what you have, how you do. This is, like I said, this is June, the 1st of June. There'll be, we'll do a month of this or until, I get too tired. But today I feel good. So stay good, stay healthy, have a good rest of the month. I'll see you later, and to good mental health. Bye bye.